Hi guys. What we're doing today is we're going to do our lecture 2. This should have been up Tuesday, but instead it is up today. So anyway, what we're going to be talking about are angles and radian measures. Now this is actually a pretty easy topic. I think it's easier than the last topic that we covered, which was on triangles and angles in triangles. So let's go ahead and get started. So you've been measuring angles in degrees for a long time, right? You have measured angles in degrees. And so you have a good sense of what a degree is for a long time. All right, and you have an idea of what that is. So if I draw a couple of angles here for you guys, I'm going to pick a different color. Let's go light blue. So if I draw an angle like this, and if I told you that that was a 45-degree angle, you would say, sure, that's a 45-degree angle. And that's because you know exactly what a 45-degree angle looks like. Okay, and that's great. But what we're going to do is we're going to define a new way to measure angles, and we're going to call it radians. Now, there's a definition for what radians are, and I'm going to give you the definition because this is a math class and that's what we do. But I don't think you're going to be using that for very much. So don't worry about it too much, but just be aware that this is where radians come from. So the idea with radians, I think I can do this, hold on. There's a circle, boom, look at that. It's like magic. Okay, good enough. That's not perfect, but it's pretty good. So let's say we have a circle like this, and I put it on a set of axes, right? X and Y. And let's say that the radius of this circle is 1. So this distance right here, that is 1 unit. Okay, because that's a unit circle. So when a circle has a radius 1, we call it a unit circle. A unit circle has radius 1. Something else we don't care about too much right now, but I'm just saying it. So there's a circle. It's a unit circle because it has radius 1. Now, what if I take this circle and I start right here and I travel along the edge of that circle far enough that this is 1. Okay? Then I've got this bottom side here. Oops, it's not what I wanted. So the bottom side here and this side here are almost like two sides of a triangle. It's not a triangle, obviously, because this side is not straight, but it's almost a triangle. And the idea for what a radian is, if I can draw one more line on here, is if I draw a line like this now, this angle right here, by definition, is 1 radian. Okay, so that's the idea. The idea is this is 1, this is 1, technically this is 1 as well, and then the angle is 1 radian. All right, and that is what a radian is. Okay, and then what you can do with that is you can try to figure out what is the conversion between degrees, like this, and radians, like this. How to convert from one to the other, from radians to degrees and from degrees to radians. Okay? And in order to do that, you have to have some idea of Well, I mean, we have to have a place to start, right? Like 1 radian is not 45 degrees, right? I drew 45 degrees on my first picture, but the second picture with the radian, that has nothing to do with 45 degrees. So we need to figure out some way that we can relate them. And the way that you will relate them is going to be like this. So hold on a second here. Let me think what I want to do. Nope, can't think of what I wanted to do. So what we're going to do instead is I'm just going to give you the conversion factor. So the idea here is, I'm going to draw it. Come on. Same as I did before, just another one, another circle. So there's another circle, and it turns out that if you, whoa, why you, no, what happened? Okay. It turns out that if you start here and you go all the way around to here and you call this angle theta there, that distance is as a measure of the angle is going to be 2 pi radians. So all the way around the circle is 2 pi radians. Oops. So that's something. And that's going to give us what we're going to use for most of our calculations. Probably, well, maybe not quite that. If I draw another couple of pictures here. Oh, no. Go back to a better color here. So if I have a circle like this, and then okay, so we have some of these. Now I'm going to draw some angles on here. So there's an angle. I'm drawing them messy, I know, but to make the lines thicker. Okay, so there's some pictures. Now, what are those angles? Well, I said that the angle in this first picture here, this one, whoa, no, why? Undo. This one is 2 pi radians, right? Now we can figure out some of the others, I think, just based on what we know about angles. Specifically, what's this first one here? I think you would believe that that's 90 degrees, right? That's a 90-degree angle. And what would the second one be? From here all the way to here. I think you would believe that that's 180 degrees, right? And this last one is 270 degrees. But what are those in radians? And so the way you would think of it is this way. If all the way around in that first highlighted picture is 2 pi, then this first angle that I drew, 90 degrees, that's a quarter of the circle, right? A quarter of the circle. So a quarter of 2 pi, if you work that out, is going to be pi over 2. So that's what 90 degrees is. And the second one, 180 degrees, that's a half a circle. So half of 2 pi. Half of 2 pi is pi. Third one, 270 degrees, that's 3/4 of the circle, and I don't know why I didn't work out the others, but I'll work out this one. If you do 3/4 of 2 pi, what you're going to get is 6 pi over 4, which is 3 pi over 2. Okay? And so that's a couple of basic angles. So you've got 90 degrees is pi over 2, 180 is pi, 270 degrees is 3 pi over 2, and the first picture that we had up here was that all the way around the circle is 2 pi radians. And you're going to remember that because we're going to be using it all of the time, right? Pi over 2 is 90 degrees. However, what do we do for other angles, right? How do we convert? So how do we convert an arbitrary angle to radians from degrees? All right, and it's easiest to do this with an example, so that's what I'm going to do. So I'm going to say convert, and we just need an angle. Could be anything. So I'm going to go with 210 degrees. Okay, 2 radians. All right, so how do we do it? So the way you do it is you start with this 210 degrees. Okay, and then what we're going to do is we're going to multiply by a conversion factor. Conversion factor. Now, what a conversion factor is it's just going to be a fraction where we relate degrees to radians. So our conversion factor could be any of these up here. So you could use this as your conversion factor. Pi over 2 is 90 degrees. But you probably don't want to. You could do 270 degrees is 3 pi over 2. But you probably don't want to. The one that we normally use is this one. 180 degrees equals pi radians. The reason we do that is because all of the others have like extra numbers in there, right? Like if you wanted to use pi over 2 equals 90 degrees, there's like an unnecessary fraction over 2. So because of that, we might as well just not do that one and stick with the 180 degrees is pi radians. Mm-hmm. So conversion factor, 180 degrees equals pi radians. Okay, now what you're going to do with that is you're going to put 180 degrees on top and pi degrees on the bottom, and pi radians on the bottom, or pi radians on top, 180 degrees on the bottom, depending on whether you're converting from degrees to radians or whether you're doing from radians to degrees. And so the way you know which one's going to be on bottom and which one's going to be top is you want the one that you're converting from to be on the bottom, like this. And you want the one that you're converting to be on top, like this. And the reason you want it that way is because if you do that, you've got degrees on top and you've got degrees on bottom, and they'll cancel, right? So you want the old unit degrees to cancel, and you want the new unit radians to not cancel. And that is what we've done. So once you have that written down, then you just multiply it out. So just reading across here, we have 210 times pi radians, like that. And then on the bottom, we just have 180. And technically we're done. Like this is now in radians, but we're not really done because we should reduce that fraction. So you've got 210 degrees. Nope, there should be no degrees. We canceled degrees. You have 210 pi over 180. And then what you want to do is basically just, reduce. reduce the fraction. So the easiest way to do that in this case is you've got 210 over 180, which is 21 over 18 pi, right? I can just knock off a 0 right away. And then from there, I say, oh, okay, well, I see that 3 goes into 18 6 times, and 3 goes into 21 7 times. So this is actually 7 pi over 6, and it's in radians. Okay? And that's how you would convert from degrees to radians, right? Let's do a couple more, just as examples here. Example. Convert negative 40 degrees to radians, right? And this will be a lot faster now that we know what we're doing. So you start with the negative 40 degrees, and then you multiply by your conversion factor, right? Remember, pi radians equals 180 degrees. And you just decide which one to put on top, which one to put on the bottom. And remember, you want the one on bottom that's going to cancel out what you started with. So like this. So what do we get? Well, the degrees cancel. You get negative 40 pi over 180, and that's in radians. And then just like before, we're going to reduce this fraction. So we can, again, knock off a 0 there, divide top and bottom by 10 basically, get negative 4 pi over 18. And then from there, I can see that 2 goes into both of those. So 2 goes into 4 2 times, 2 goes into 18 9 times. And you get negative 2 over 9 pi radians. Oops, why you do this? Oh no. Sad. I'm going to leave it there as a mark of my failure. All right, negative 2 pi over 9 radians. Okay, and so that's how you're going to convert anytime you have to convert degrees to radians. Now you can convert the other way as well. So to convert radians to degrees, you use the same conversion factor. However, it's going to be upside down. So if I want to convert, let's say, what do I want? Let's say pi over 12 radians to degrees. So this time we're starting with radians and we want to go 2 degrees. So you start out with this, with your angle, just like you did before, pi over 12 radians, and then you're going to multiply by your conversion factor. But on your conversion factor, you want radians on the bottom because we're trying to cancel out radians. So you've got pi radians equals 180 pi, or 180 degrees, just like before. But this time, you're going to put the 180 degrees on top, and you're going to put the pi radians on the bottom. And that is so radians will cancel, and degrees will be left. So do you see how that works? You just have to get the conversion factor the right way around. So what are we going to get when we multiply this? We're going to get the pi times 180 degrees on top. So that's pi 180 degrees. And then on the bottom, we've got the 12. Oops, that is not what I wanted. On the bottom, you've got the 12 and the pi. Like that. Okay, and just like last time, we've got to do some canceling. So the first thing that you can cancel right away is the pi there, right? There's pi on top, pi on the bottom. So then you're left with, what do we have? 180 degrees on top, and then on bottom we have 12. Now, grab a calculator, something like that, see if it goes in evenly. I don't have a calculator in front of me, so I'll just do this by hand. So I think that 3 goes into both of these. So 3 goes into 12 4 times. 3 goes into 180, I think 60 times. So then I've got 60 degrees over 4. And from there, I'm pretty sure that 60 over 4 is 15. Does that sound right? I don't know. Hopefully, yeah. 15 and 15 is 30. Double 30 is 60. All right, so that's right. $15 degrees. Okay, so you use that conversion factor exactly the same way. Now, I'm going to try this. I'm still new to using an iPad for making these notes here, so let's hope for the best. Do this. We are in YouTube. We're watching videos of somebody who takes foxes and gives them a home. But that's not what we're trying to do. We're trying to go to Wolfram Alpha. Okay. So here's a site that you may or may not be familiar with. It's a good site for any kind of math stuff that you're trying to do. So one of the nice things is you can say, convert, what were we, pi over 12 radians to degrees. You can just ask for it, hit enter, and it'll do it right there for you. 15 degrees. That's nice. And of course it can do it the other way. You can say, convert 210 degrees to radians. Enter. And there you go. 7 pi over 6 radians. Easy peasy. And so a site like this is going to be pretty helpful as we go on in the class. So you want to use those, maybe check your answers when you're doing them on the computer anyway. And the more you get right in the row, the faster you're going to be done with your homework, right? So you don't want to get too many wrong. So maybe work through the problems, check your answer, and then type them in and hit submit. And you'll get done a little bit faster on your homework. So the next thing we're going to be doing, I think, is we're going to be talking, well, we're almost ready to talk about like reference angles, I guess. No, that's a lie, actually. We're not. Let's just go back to the notes. Where are the notes? There? Ha ha ha, there they are. Okay, so another topic that you're going to have on the homework, other than converting back and forth between radians and degrees, is what they call coterminal angles. Now, before we talk about coterminal angles, we have to make sure that we understand what standard position is. So I need to define that. So let us do that. Definition. Whoa. Why you do this? That's very shaky. Oh well, I am not starting a video 25 minutes in, so let's just go with it. Definition. Oh no. Okay, I've got an idea. Don't read on the screen, guys. All right. Hopefully this is going to be good now. Yeah, okay, we're back to working properly. Okay, definition. Okay. Standard position. So an angle theta in standard position has its initial side I don't like the way I'm wording this. So an angle in standard position just erase. An angle in standard position has the positive x-axis as its initial side. And its terminal side and is measured what direction? Counterclockwise? Positive angles are measured counterclockwise. Now that doesn't sound like a good definition, and it isn't. But the thing about standard position is that it's awkward to write down the definition of standard position, but it's easy to understand what standard position is. So what standard position is simply this. So you've got the origin, and you've got this. This is your initial side, always, for standard position. And then the terminal side is just wherever it is, but it starts at the origin and then goes wherever. So like, you could have this as your terminal side if you want. All right, and the reason we say that positive angles are measured counterclockwise is we're saying when you measure from the initial side to the terminal side, you start here and you go in the counterclockwise direction like that, and if you do, that's going to be a positive angle. All right, and so that's my angle theta. And so anytime you have an angle like this, that's an angle in standard position. All right, so all of the angles that I drew so far were in standard position, right? Like all of these are standard position because in each case I stuck the initial side right here, right here, right here, right here, and in each case you'll notice that I measured counterclockwise from the initial side. So all of those angles were in standard position, and when they say standard position, that's what we're talking about. Okay, and if that made sense to you, just that the initial side is kind of fixed right there, then standard position makes sense to you. That's what you need to know. Okay, so that's what an angle in standard position is. Now you do have negative angles as well in standard position. I'll show you what that looks like. So like if I have an angle like this, let's say that this is, I don't know, let's say 70 degrees. That's what a positive angle in standard position looks like. If I take a similar angle like this, but I go this way, if you measure clockwise, that's how you get a negative angle. Okay, so positive angles are counterclockwise and clockwise is negative. Okay, counterclockwise positive, clockwise, negative. Okay, and there are some angles. Now, something that you may or may not have realized, probably not, there's no reason to, is that you can have the same angle written different ways, right? If I take an angle in standard position like this, like let's just say this angle, no surprise that that angle is 90 degrees, right? But what if I went the other way around? What if I went that way? How far is it? Well, if I, in the negative direction, that was 3/4 of the circle, right? And 3/4 of the circle is 270 degrees. So it's either 90 degrees or negative 270 degrees. They both have the terminal side in the same place. So you can have, let's see, the same terminal side and initial, but the initial side is always in the same place, so it's really the terminal side that changes. The same terminal and initial sides can give you different angle measures, I'll say. Right? Like we just saw 90 and negative 270 have the same terminal and initial sides. Okay? These type of angles, this type of angle, these type of angles, I said these, I wrote this. These types of angles are called coterminal angles. Why are they called coterminal angles? Because literally the terminal side is in the same place, right? So this right here, same terminal side, coterminal. All right, and so that is a coterminal angle. Now there's an infinite number of coterminal angles actually for every angle. So think about it. If I've got an angle like this, I'm gonna make one up here. So let's say that this is, I don't know, 110 degrees, right? So let's see, angles coterminal, terminal with 110 degrees. All right, here's some of them. One of them is if you just go around this way, what would it be? Well, hopefully you remember that all the way around a circle is 360, right? So if it's 110 on one side, it's probably, what, 250 the other direction? And I know it's negative 250 because we measured in the negative direction there. So negative 250 degrees is coterminal with 110. But there's another way to get coterminal angles as well. What if we start from here again and we go all the way around the circle and then we keep going? Wait, stupid iPad. What if you go all the way around the circle and keep going like that? What about that? What's that angle? Well, the idea there is if you go all the way around a circle, then that's 360 degrees, right? Like this is 360 degrees. And if the angle is 110 degrees, then 360 plus the 110, which would be 470 degrees, that should be in the same place as 110, right? Because just one full revolution like that will get you back to the same place. Okay? If that makes some kind of sense to you, then what I'm about to write should also make sense to you. So here's what I want to write. Let's see. If you start with an angle, theta, all right? Adding or subtracting 360 degrees gives you a coterminal angle. And the reason for that is what we just said, right? 360 degrees is a full revolution around the circle, so it drops you off where you started, okay? So that's a key here. Why is it a key? Because there's a specific problem type that they're going to ask you to do. So what they're going to ask you to do is something like this. So problem type. Find an angle, or the angle, in 0 to 360 degrees coterminal with angle blank. All right? So they're going to give you an angle and they want you to find an angle that's coterminal to it. Okay? And the key to doing this is understanding what I wrote right above it, right? You can add or subtract 360 degrees and you still get a coterminal angle, okay? So these problems aren't hard once you understand that. So like, here's an example. Find an angle in 0 to 360 degrees, coterminal with, could be anything. I'm just going to say 800 degrees. Okay? And here's what you do. All you do is add or subtract 360 degrees until you get something in the range you want. Right? So looks like this. You start with 800 degrees. Well, that's not in 0 to 360, right? It's too big. Too big. Well, how do you make it smaller? Subtract 360, right? You subtract 360 and you haven't changed the angle at all. So you need 800 minus 360. Calculator? Said I don't have a calculator, but I better find one. All right. So 800 enter 360 minus 440 degrees. Now that's still not in 0 to 360. It's still too big. So what are you going to do about it? Subtract another 360. You get 80, right? Well, 80 is in between 0 and 360, and that's all you were looking for. So the angle, so 80 degrees is coterminal Coterminal with or to 800 degrees. Okay? And that's all you have to do. If you start out with a negative number, then instead of subtracting 360, you add 360, like so. Example, find an angle in 0, 360, coterminal with, I don't know, negative 500 degrees. All right, so again, you start with the negative 500. That's not in 0 to 360, right? Because it's negative. So I'm going to write too small, but really I mean too negative, right? Well, if I mean that, why don't I write that? Too negative. So in order to make it positive, you add 360. What do you get? So you have negative 500. Oh, come on. Negative. Where's negative? All right. 360, 500 minus. So you add those together, you get negative 140 degrees. Well, that's still negative, right? Still too negative. We need a positive angle. So what do? Add 360 again. We get 220. That's between 0 and 360, and so we're done. So 220 is coterminal to negative 500 degrees. All right. And I believe that that's everything you need on this homework. But rather than stop the video right this second, I'm just going to jump through the questions real quick. So it's kind of sad, but something that I'm not liking about Newton Alta so far. Oops, I already found something. Something I'm not liking about Newton Alta so far is that I can't actually see the exact questions that you see unless I just want to do the entire homework set, which is fine. I'm perfectly happy to do the entire homework set, but if I want to make sure that I did everything that you guys are going to do, it's a little bit tricky. So just babbling nonsense for a few seconds while I go through the problem set. Okay, pretty sure that the only thing we haven't talked about is quadrants. That's good. All right, last topic. Quadrants. Okay, so basically, when you have angles in standard position, we've got an XY plane, and we divide the XY plane into 4 quadrants. So the XY plane is divided into 4 quadrants, like so. 1, 2, 3, 4. Why are they Roman numerals? I don't know. They just are. Okay, so we just use Roman numerals. So it's divided up in that way. So every angle in standard position has a terminal side. And that terminal side is going to be in one of those quadrants. one of the quadrants. Now, I say that, but that's actually not actually true, is it? Right? Because like 90 degrees is right between 1 and 2 and so on, except 90, 180, 270, dot, 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 right? But otherwise, you have angles that are in one of the quadrants. And so the terminal side is in one of the quadrants, and if the terminal side is in one of the quadrants, we say the angle is in one of those quadrants. So example, what quadrant is 150 degrees in, right? And so the way you would do this is you would just say, okay, well, I've got an XY plane right here. I know that like 0 degrees is right here, right? And I know 90 degrees is right here. And I know 180 is right here. 270 is here. If you keep going, 360 is right there. And you can just keep going forever. But we don't have to. So we've got 150 degrees. Where is it? Well, 150 is in between 90 and 180, right? So you've got 90 here and you've got 180 here. So 150 is like in here somewhere like that. In between 90 and 180. So then you would just say, well, what quadrant is that? Just look at the picture. You can see that that's quadrant 2. Right? This is 2. So 2. That's the answer. Okay? Now, that seems like it's pretty easy. Like, where would it be hard? The only time that this would be hard is if you have an angle that's like bigger than 360, or it's like negative or something like that, and you have to work a little bit harder to figure out where it is. So like example, what, that's not a W. What quadrant is negative 1111 degrees in, right? Probably you have no idea. Well, guess what? Neither do I. So in order to do it, you're going to have to figure out where that angle is. And that's exactly why we were doing this find an angle coterminal blah, blah, blah thing. Okay. You just want to find out where negative 1111 is. So you say, okay, negative 1111 degrees. What do? Add 360, right? Because it's negative. So we got 360, 1111 minus negative 751. Well, I still don't know where that is. Add another 360. Negative 391. I still don't know. I'm going to write it here. 391. Add another 360. Negative 31. Now, I actually do know where negative 31 is, right? Because I know this is 0, right? And if you went negative 90, it'd be down there. So negative 31's got to be like that. But if you pretend that you didn't know that, you could add another 360 and get 329 degrees. And then 0, 90, 180, 270, 360. So where is 329? It's in between 270 and 360. Down there. 329. All right, so what quadrant is that? Well, that's easy, right? This is 1, 2, 3, 4. So where are we? We're in quadrant 4, right? Answer. quadrant 4. Okay, and so now that really is it for this lecture. So again, pretty easy. Good luck with the homework. I'm going to get video or even 2 videos up tomorrow.